4.4 Intermolecular Forces. At the end of the lesson, the student should be able to describe the intermolecular force, that is van-der Waals forces, and hydrogen bonding. Intermolecular force. Intermolecular force are attractive force between molecules. For example, these two molecules of hydrogen chloride, between these two molecules, there is the intermolecular attractive force. This attractive force generally much weaker than covalent bond. The strength of the intermolecular force determines the physical properties of the substance. So there are two types of intermolecular force. The first one is van-der Waals forces. The second one is hydrogen bond. There are two types of force in van-der Waals forces. The first one is dipole forces. Example, hydrogen chloride is between polar molecules. Second, dispersion forces, or we also can call it as London dispersion forces. Example, argon, non-polar molecule. Okay. For hydrogen bond, example, water and methanol. Dipole forces. A dipole forces exists between neutral polar molecules. For example, hydrogen chloride. So in molecule hydrogen chloride, hydrogen is more electropositive compared to chlorine. Chlorine is more electronegative than hydrogen. So the attractive force is between the partially negative and the partially positive. This is dipole forces. The strength of dipole forces depends on the dipole moment of the molecule. A more polar molecule have stronger dipole forces. Example, the dipole forces in hydrogen chloride are stronger than in hydrogen bromide. So, chlorine and bromine are in the same group, but chlorine is more electronegative compared to bromine. So, dipole forces in hydrogen chloride are stronger than hydrogen bromide. Relationship between boiling point and dipole moment. So, in this table, we have propane, dimethyl ether, methyl chloride, acetaldehyde, acetonitrile. Okay, the molar mass is comparable, but the dipole moment is increased from propane to acetonitrile. And the boiling point also increased from propane to acetonitrile. So, the greater the dipole moment, more polar the molecule, and the higher the boiling point. So, relationship between boiling point and dipole moment is directly proportional. London dispersion forces exist in all atoms and molecules. Non-polar molecules do not seem to have any basis for attractive interaction. At any instant, one side of the molecule has higher electron density, while the other side has lower electron density. At this instant, the atom or molecule becomes a small instantaneous dipole, then induce a dipole on the neighboring atom and molecule. Due to electron repulsion, a temporary dipole on one atom can induce a similar dipole on a neighboring atom, which can cause the neighboring atom to be attracted to one another. This interaction is called the London dispersion forces or just dispersion forces, and only significant when the atoms are close together. Polarizability is the ease with which the electron distribution in the atom or molecule can be distorted. Polarizability increases with greater number of electrons, more diffuse electron cloud. Dispersion forces usually increases with molar mass. So let's see this table. So we have CH4, CF4, CCl4, CBr4, Cl4. Okay. CH4 compared to Cl4. Cl4 is greater molar mass. So the melting point for Cl4 is the highest. Hydrogen bond. Attractive force between the positively charged hydrogen atom of a molecule and the negatively charged electronegative atom of another molecule. It is a special type of dipole-dipole forces between hydrogen in polar bond NH, OH, or FH of a molecule with NO or F of another molecule. For example, hydrogen fluoride. So, there is a attractive force between the hydrogen with fluorine. So, this is the hydrogen bond. Another example is water, ammonia. Water with ammonia. Water with ammonia. Ammonia with HF. Ammonia with hydrogen fluoride. So this is example of hydrogen bond. So you need to remember FON. Hydrogen with fluorine or oxygen with nitrogen. So technique to determine and show the existence of hydrogen bond. Find the partially positive hydrogen. The hydrogen must be bound to F or O or N. Find F, O, or N in the other molecule. The atom can be bonded to any atom. Example. So we have here hydrogen that bond to nitrogen. Okay, then another molecule here, we have oxygen. Oxygen is partially negative, so there will be a attractive force between hydrogen and this oxygen. So this is what we call hydrogen bond. 4.5 metallic bond. At the end of the lesson, students should be able to explain the formation of metallic bond using electron C model and explain the factor that affect the strength of metallic bond. Metallic bond. Metallic bond can be defined as the electrostatic force between the positively charged metallic ion and the sea of electron. So this is electron C model. So this is the metal cation, and this one is the valence electron from metal. So we can see that the metal has positive charge, means it has one valence electron. So we have total 8 cation here. So we must have 8 valence electron. So as a reminder, the number of electrons in the model must be equal to the valence electron released by the metal atom. For example, if the metal is magnesium, magnesium have 2 valence electrons, and if in this model there are 8 magnesium, it should have 16 electrons. electron free model. In a metallic bond, metal atom can be imagined as an array of positive ions immersed in a sea of delocalized valence electrons. These delocalized electrons are not bound to individual atoms, and they can therefore serve to bind large number of metal atoms together. A metal which has more valence electrons will have more electrons to contribute to the sea. K ion become more positive, hence stronger attraction between electron and K ions, therefore stronger metallic bond. So the strength of metallic bond is directly proportional to the number of valence electrons, inversely proportional to the cationic size. So the bonding will be weaker in sodium compared to magnesium, compared to aluminium, as aluminium has the greater number of valence electrons compared to magnesium and sodium.